Let's look at another example of a paired T interval. So 2 drugs used for the treatment of glaucoma were tested on 7 dogs. Drug A was administered to one eye of each dog and drug B to the other eye, and those eyes were randomly chosen. Pressure measurements were taken 1 hour later on each of the eyeballs of the dogs, and they are provided for you actually on the spreadsheet for this particular chapter. You are allowed to assume that the pressure measurements and the differences between them are normally distributed. Find a 90% confidence interval for the mean difference in pressure readings between the 2 eyes. So my subtraction or my difference, I'm going to use A minus B on this one. So that way we're all on the same page. And what I would like you to do is to go ahead and pause the video, give this one a try. And then when we come back, I'm actually going to fly through it pretty quickly. So you'll have wanted to have given that a try before we get going. All right, so hopefully you gave that a try. We're going to go ahead and fly through these answers here. So I have a 90% confidence interval for the mean difference, eye pressure, drug A versus drug B. I do have paired data. We talked about that before we paused the video. They are randomly chosen. I don't know that the dogs themselves were necessarily randomly selected, but at least the eye that the drug was applied to is randomly chosen. We are allowed to assume these are differences are normal. That was stated in the problem. Our sample size was 7, and I got a standard deviation of 0.0269. Okay, which gives me a paired T interval. And I had a D bar of 0.0271. We can hop over and take a look at that quick on Excel. All right, so here's my Excel spreadsheet for the glaucoma dogs. And I did A minus B. Okay, so pressure A minus pressure B. These are all of my entries. There's my standard deviation, the 0.0269, and there is my average, my D bar, 0.0271. And then we'll just take those numbers and put them in our Excel calculator. Okay, so here's our Excel calculator. You can see here's my 90% confidence level, 0.9. I put X bar in, 0.0271, standard deviation, 0.0269. Sample size is 7. So my lower bound is 0.007, and my upper bound is 0.047. We'll round up there. All right, and then let's go write our conclusion. All right, so our conclusion here is we are 90% confident that the mean difference in eye pressure between drug A and drug B is between 0.007 and 0.047. Okay, and I want you to notice something. So 0 is not in this interval, okay, which means that A minus B, because that's how we did our subtraction, and these are all positive, is always greater than 0. Okay, which means that the pressure in the eye that got drug A is greater than the pressure in the eye that got drug B. Okay, and so for glaucoma, you actually want low pressure on your eye. You don't want high pressure. So that means it looks like B actually is giving the lower pressure in the eye. So B would be the better medication to use here. Okay, so remember in the previous example, 0 is in the interval, meaning there might not be any difference between those two titers. But in this one, 0 is not in our interval, meaning that there actually is a difference between drug A and drug B.